Welcome back to my channel. Today we'll be going over some more common dplyr functions used in basic data cleaning. As always, we'll be using the Palmer Penguins dataset along with the tidyverse. So as usual, let's go ahead and get those things loaded in. All right, so the first function I want us to look at today is the sample function. And what this function allows us to do is basically just take a random sample from a bigger data set. So it's a fairly simple syntax. All you have to do is basically call your data set you want, the sample underscore n, and then the number of random samples you want. So in this case, we'll be doing 100 random samples. So let's go ahead and do this. Now, one thing you want to do when you do a random sample is you want to make sure that your sample is somewhat similar to your data set. So a good way to do this is to look at a measure of central tendency, so something like the mean or the median, and a measure of variability, something like your standard deviation. And what this will allow you to do basically is to make sure that your data set that you've sampled from is neatly represented in your sample. So a good way to do this is simply just to call SD and mean for your two sample set, your two data frames, and then just make sure that they're somewhat similar. So if we do this, oh, actually there are missing values here. So let's just go ahead and get those fitted with a na.rm equal true to temporarily ignore missing values, because this is just an example. So if we do this again, what do we see? We see that in terms of standard deviation, the two sets are not that far off. And again, in terms of mean, at least when it comes to body mass, are not that far off either. So you can also assume that when it comes to things like bill length and flipper length and bill depth and things of that nature, they should be roughly similar as well. The next thing I want us to look at is the slice function, which basically allows you to take a predetermined slice out of your data set. And a good way to combine, or a good function to combine this with, is the arrange function. So for example, if you have a data set and you want the top 5 or the top 10 by some measure, for example, in this case we're looking at bill length, and we want the top 5 entries by bill length, what you can do is basically take your data set, which is penguins, call an arrange function, set it to a descending, so from largest to smallest in terms of bill length, and then just call a slice function, so meaning you'll want the first all the way through to the 5th entry. And so if we run this, what we'll see is that basically we have 5 entries. And if we look at bill length in millimeters, these should in theory be the biggest one. So just to make sure that we didn't indeed get the longest, I suppose, bill lengths, let's go to the original set, sort this by bill length. And what we see is so 59.6 and 58, 59.6 and 58. So this seems to have worked properly. Great. And finally, the last function I want us to look at today is the lag function. And basically what this will allow you to do is calculate a difference from one entry to the other. So for example, if we look at this, I'm gonna call the penguins data set. I will then arrange it by bill length, so meaning it will be from the smallest or the shortest bill length to the longest. Again, species, I just want everything to be done by species, because you do have to arrange it by some other metric. I mean, you don't have to, but in this case we will, because bill length does change considerably by species. And then you'll call a mutate function. And then you will create a new variable. So in this case, we'll call it bill change, because it will be the change in bill length based on entries. And then what you'll do is you'll call your bill length, and then you will minus the lag of the bill length, whereas the lag here will basically be calculating the difference from one entry to the next. Or so, not to the next, sorry, from the one previous in this case, because it's lag, not lead. So if we call this and we go look at, this will be what, bill length diff, and we go look at this, we've created a new variable called bill change. Now, obviously, the first one is going to be not available because there is nothing to compare it to previously, right? And what we see here is if we look at 1 and 0.4 and 0.5, 0.1, basically what it's telling you is in millimeters how different is the previous bill length to the one from that entry. So if we look here, for example, we have, actually, let's just look here. We have 33.1, and here we have 32.1. And here we have a change of 1 millimeter. This seems to track, so therefore our transformation was successful. Now, why might this be useful? Well, as I've said, build length should, species are usually determined by physical characteristics, right? Like how tall are they, how big are they, how long are their flippers, how long are their feet, or so on and so forth. And so what you can do when you create a variable like this is you can say, hey, I now have all the changes in build length, and I know their build length will change by species because that's how species are determined. But how about how different are their build lengths within a species? And so, creating a build change or any kind of change in, showing kind of a variability between a physical characteristic can be useful in further exploring, how different the penguins are. And so that's what I've done here. And basically, I've called the dataset the penguins length difference, and then I've grouped by species because I'm interested in species differences. And then I've asked it to summarize a new variable called average build change, which is basically just average or the mean of the build changes. And then again, I've called an na.rm equal true because there are some missing variables here and I don't want it to interfere with the calculation. And if you look at the output, what are you seeing? You're seeing that on average, it seems that the chinstrap penguins are, or rather have more variability when it comes to build length than the analyses or the gentoos. And that's all I have for you today. In the coming videos, we'll be looking at outliers, how to spot them, how to detect them, and different methods of dealing with outliers depending on what kind of data you have and just how much time you're willing to invest into cleaning your data, because there are some simple ways of doing it and there's some much more complicated ways of doing it. After that, we'll be covering how to clean string variables, which is something that is extremely common if you're going to be scraping data or having weird data entry, like with surveys and things of that nature. And then that'll culminate my sort of mini series on how to clean data. And after that, I'll be posting up a video on basically how to do a full-on, from start to finish, data cleaning project. Yeah, that's it. I still don't have an intro, so yeah, I hope you have a good day.